My name is Phoenix Wright. I'm a defense attorney. This is a case I took a few years ago. I was defending a mathematician named Kurt Godel. Bertrand Russell and Alfred Whitehead had a problem. Godel had shattered their life's work, the Principia Mathematica, with a proof that had shaken the foundations of logic and mathematics. Russell and Whitehead sued Godel, and it was my job to defend him. Problem was, how could I prove something that is unprovable? Court is now in session. We will proceed in the matter of Russell and Whitehead versus Mr. Kurt Godel. Counselors, are you ready? The prosecution is ready, Your Honor. The defense is ready, Your Honor. This is most certainly an unusual case. I've tried many criminals, but a mathematician, this doesn't add up. Prosecutor Edgeworth, you may call your first witness. The prosecution calls Detective Gumshoe to the stand. Detective, please tell us what you know about this case. In 1913, Bertrand Russell and Alfred North Whitehead wrote a paper called the Principia Mathematica. It was huge, pal. It defined all mathematics, laying it out in a formal and precise way. Not only that, but it was designed from the ground up to avoid a certain problem. But then Godel found some way to prove that their system was incomplete, and that was the end of that. Detective, in your testimony you mentioned the word incomplete. Can you explain to us what that word means? Well, first you gotta know when something's complete before you can say it isn't, pal. We're talking about formal mathematical systems here, right? So when we say complete, we mean that every true theorem has a proof. So when a formal system is incomplete, that must mean there are truths that don't have a proof. In other words, to prove something that couldn't be proven, I'm starting to see what Godel meant. Detective, exactly what problem did Russell and Whitehead want to avoid? They wanted to avoid self-reference in their system. Why was that such a big problem? Well, they thought that self-reference paradoxes would lead to self-contradiction. Kind of like saying this statement is false. If you think it's false, then it can't be false, so it's true. But that just makes it false all over again. It makes my head hurt, pal. But anyway, they got rid of self-reference pretty well. I don't know how they did it, but they did it. Objection! Actually, Detective, you're wrong. It's totally possible for self-reference to exist in that system. And that's exactly what we need to demonstrate to prove that my client is right. Godel came up with a simple trick called Godel numbering that would let a system like the plaintiff's talk about itself. That's a form of self-reference. So what you're saying is that a theorem of mathematics can be turned into a number? Exactly. And from there it's no stretch to see how theorems can start talking about their own Godel numbers. They can even assert whether they are provable or not. See where I'm going with this, Detective? But how does that Godel numbering trick work anyway? Objection! It doesn't work, Your Honor. That's what my next witness will prove beyond doubt. Call Mr. Bertrand Russell to the stand. My name's Bertrand Russell. I'm a mathematician, and I'm gonna show you all why Godel's numbering trick is bogus. What Godel ended up doing was creating a really similar system to the Principia Mathematica called Typographical Number Theory, or TNT. The exact details of the system are a little complicated, so I won't get into them. But it's just as powerful as ours. TNT's got natural numbers, basic operations, even variables. I have to admit, TNT was exactly like our system, and just as powerful. So how is this relevant to Godel numbering, Mr. Russell? Well, whatever's true about TNT is true about other systems like ours, right? So Godel had this trick up his sleeve. Godel's trick was to assign a unique number to each symbol in TNT. The numbers could then be placed back to back to make really big numbers. With the right combinations of digits, you could make theorems or even entire proofs, all out of numbers. The big number that you got by replacing the symbols in a statement with their associated numbers is called that statement's Godel number. It's a neat trick, but it certainly doesn't help your self-reference idea, Mr. Lawyer. Mr. Russell, in your testimony, you stated the following. You could make theorems or even entire proofs all out of numbers. Is that correct? Yes, but Godel numbering has nothing to do with self-reference. Objection! Actually, Mr. Russell, Godel numbering has everything to do with self-reference. Every theorem of TNT has a Godel number, right? So instead of talking about the relationships between symbols, we can talk about the relationships between Godel numbers. Yay! In fact, a statement about a system like TNT can be translated with the help of Godel numbers to a statement within TNT. Ah!
Objection!
Your Honor, that idea is completely and utterly absurd. Mr. Wright, how can a statement talk about itself? Well, Mr. Edgeworth, maybe the defendant will be able to show you how. Call Mr. Kurt Godel to the stand. If you please, then, Mr. Godel. With pleasure, Your Honor. We need the ability to say whether a certain theorem has a proof. This can be done through a TNT theorem we will abbreviate as P for provable. For two values, m and n, P of m and n can be interpreted as m is the TNT proof of n. Finally, we need to be able to substitute values in for undefined variables. It's just like solving an equation by substitution. The theorem we need, called sub, replaces all undefined variables in one Godel number with a second Godel number. For example, the expression sub of a, b, c replaces all undefined variables in theorem A with the number b. The result of that substitution is c. If a and b are the same Godel number, we can insert a theorem's Godel number into itself. If you understand this, then you will understand how we can use this to make an unprovable theorem of TNT. So we can make a theorem talk about its own Godel number by forcing it to eat its own words, in a sense. Then, if this expression were true, basically it would mean that A prime is what you get by inserting A double prime into itself. Exactly, Your Honor. Now, are you ready to see the statement that is unprovable in TNT? The undecidable theorem G. Can you handle the truth? First, we need to make a formula we call U. This is G's uncle. It looks like this. What this says is, the substitution of A double prime into itself does not have a proof. Now all we have to do is insert U into itself wherever we see A double prime. After all, A double prime was deliberately left undefined. And now we have the unprovable theorem G. That theorem looks exactly like the one we just saw. Are you sure you're not doing it wrong, Mr. Godel?
Objection!
Take another look, Edgeworth. What you said is, the substitution of A double prime into itself does not have a proof. But what we just did by letting U be equal to A double prime was insert A double prime into itself. What G says is, the substitution of U into itself does not have a proof. However, G is the substitution of U into itself. No, there must be... Oh, you see the problem too? We can reread G as saying, the formula whose Godel number is G does not have a proof. Or, taking it one final step further, G is not a theorem of TNT. So that's what he meant by proving the unprovable. Now I get it. You forgot one thing. Just because G is unprovable doesn't mean it's true. Okay, Edgy, let's assume that G is in fact false. What that would mean is the opposite of what G says is true. That means that G is a theorem of TNT. But all theorems have a proof, and you can't prove a false statement. Clearly a contradiction, Your Honor. And that's why G must be true, and remains forever undecidable. Exactly as planned. If there is no more testimony to be delivered, then I'm prepared to hand down a verdict. This was a most complex, extremely technical and abstract case. Many of you may leave the court today not having understood much of what was going on. What you need to understand, and what I'm going to base my decision on, is the key point, that Godel made self-reference possible in a system that was designed to keep self-reference out. Based on the defense's demonstration of this fact, this court finds the defendant, Mr. Kurt Godel, not guilty. Thank you, Mr. Wright. You did a marvelous job. Your strategy was brilliant, but how did you figure it out so quickly? Elementary, my dear Godel. Contrary to a normal case, we won because we were able to prove that there was no proof. Court is adjourned.